Hello all, my topic is Introduction to Poisson Distribution. So what is Poisson distribution? It is defined as a discrete frequency distribution that gives the probability of the number of independent events that occur in a fixed time. So when do we use Poisson distribution? When the independent events occurring at a constant rate within the given interval of time is provided, we use Poisson distribution. Here comes the definition of Poisson distribution. So it is defined as a discrete probability function. That means the variable can take any specific values in a given list of numbers, probably infinite. A Poisson distribution measures how many times an event is likely to occur within X period of time. In other words, it results from the Poisson experiment, which is a statistical experiment that classifies into two categories such as success or failure. Poisson distribution is a limiting process of the binomial distribution. A Poisson random variable x. It defines the number of successes in the experiment. This distribution occurs when there are events that do not occur as the outcomes of a definite number of outcomes. So Poisson distribution is under certain conditions, which are as follows. The number of trials n tends to infinity. The probability of success p d tends to 0. So the product np is equal to 1, which is finite. Now let's see the formula for the Poisson probability distribution, which is given as PR is equal to e power minus lambda into lambda r divided by r factorial. Here r represents the number of rare events in a unit of time, space or volume. Lambda is the mean value and e is the base of natural logarithms, and its value is equal to 2.71828. So now let's see the derivation of how the formula comes. For a binomial experiment, the probability of R successes in n trials is given as PR is equal to NCR p power R q power n minus R. So in the place of C, we're going to substitute the formula C is equal to NPR divided by R factorial is equal to n into n minus 1 into n minus 2 till n minus R plus 1, the whole divided by R factorial. So now let's substitute this formula in the first formula. So we get as n into n minus 1 into n minus 2, which gives n minus R plus 1, the whole divided by R factorial into p power R q power n minus 1 n minus r. So this gives the first equation. So it is further simplified into n by 1 into n minus 1 divided by 2 till n minus r plus 1 divided by r into p power r q power n minus r. In this equation, we are substituting the values of r as 1, 2 till r. So the next step, we are going to substitute r minus 1 in the place of r. So we get p r minus 1 is equal to n by 1 into n minus 1 by 2 till n minus r plus 2 divided by r minus 1 p power r minus 1 q power n minus r plus 1, which is simplified as n into n minus 1 till n minus r plus 2 divided by r minus 1, the whole factorial, into p power r minus 1 into q power n minus r plus 1. This gives the second equation. So now the first equation is written as PR is equal to n into n minus 1 into n minus 2 into, which is written etc. till n minus r plus 2 into n minus r plus 1, the whole divided by r into r minus 1, the whole factorial, into p power r q power n minus r. So let's see the things which are written in the box. P power r q power n minus r. Now we are multiplying and dividing by pq. So we are getting p power r minus 1 q power n minus r plus 1 into p divided by q. So this is simplified as p power r minus 1 q power n minus r plus 1 into p by q. So we are writing this equation as PR is equal to n into n minus 1 into n minus 2 till n minus r plus 2 into n minus r plus 1 the whole divided by r into r minus 1 the whole factorial into p power r q power n minus r into pq divided by pq. So we are getting PR is equal to n into n minus 1 into n minus 2 till n minus r plus 2 into n minus r plus 1 the whole divided by r into r minus 1 the whole factorial into p power r minus 1 q power n minus r plus 1 into p by q. Here we are taking n minus r plus 1 the whole divided by r into p by q as common, and then we are writing the remaining the left and the right side. R into n minus 1 n minus 2 till n minus r plus 2 the whole divided by r minus 1 the whole factorial p power r minus 1 q power n minus r plus 1. Here the things which are written in the right side, n into n minus 1 n minus 2 into till n minus r plus 2 the whole divided by r minus 1 the whole factorial into p power r minus 1 into q power n minus r plus 1. It is the value which is p r minus 1. So now pr is equal to n minus 1 plus 1 sorry n minus r plus 1 p by qr into p r minus 1, which is equal to n into 1 minus r minus 1 divided by 1 into p by qr the whole into p by p r1 r minus 1 sorry r minus 1. So this is the third equation. So now we are applying the condition that n is very large and p is very small. So when n is very large, we have 1 minus r minus 1 by n is approximately equal to 1, which is the equation A. And if p is very small, q is equal to 1 minus p is approximately equal to 1, which is the equation B. So we are substituting the value of A and B in the third equation. So we are getting PR is equal to NP by R into PR minus 1. So we see that the value of lambda is equal to NP. So we are getting as lambda by R into P R minus 1. Hence we are substituting R is equal to 1, R is equal to 2 and so on. So we get P1 is equal to lambda by 1 P naught comma P2 is equal to lambda by 2 P1 is equal to, here we are substituting the value of P1 in the next one. So we get lambda square by 1 into 2 into P naught. P3 is equal to lambda by 3 P2. We are substituting the value of P2 in P3. So we are getting lambda cube by 1 into 2 into 3 into P naught and so on. In general, we are getting the fourth equation, which is PR is equal to lambda power R divided by R factorial P naught. This is the fourth equation. And we know that summation of R is equal to 0 to